All right. Uh, post hoc follow-up analysis on a chi-squared test. Post hoc means after the fact or after the procedure, I think. I'm not real good with Latin, but the issue is here, if you reject the null and conclude that the distributions are different, or that the distribution is different than what's claimed, the next obvious question is, which two or more proportions were different? It's got to be at least two. You can't have one. Well, just to look back at this with these hockey players, we expected 20, right? We couldn't have it that all three of these were exactly what you would expect and this one was somehow different. If this is higher or lower, then the difference has got to be seen someplace else as well. Like if this is higher, then something over here is going to have to be lower. So you're kind of looking for two or more places that could be different, or perhaps even all four places that are different. Informally, we can look at the individual components of the chi-squared test statistic to help us answer this question. So let's look at an example and talk about how we can use these components to see where our differences lie, or where our differences may lie. This is more like an informal procedure. Moose all around. A study was conducted to determine where moose are found in a region containing a large burned area. A map was partitioned into the following four habitat types. So we got the burned area, 1, but not by the edge. 2 is in the burned area but on the edge of the burned area. And then 3 is outside the burned area but on the edge. And then 4 is outside and not on the edge. So do the moose prefer a certain habitat type or not? So then they did I'm not going to read this all. They used an aerial survey to look at the proportion of the total acreage. So 31% of the area was area that was burned. 10% was area habitat 2, 10% habitat 3, and then 46% habitat 4 outside the burned area. And then they looked at how many moose they found in each of these regions. So you wouldn't expect these moose to be equally distributed because the areas are not equally distributed. So you would, if the moose had no preference over their region, you'd expect the distribution of these to follow this distribution here. However, if those distributions don't match, then perhaps maybe the moose like one of these regions better than another. All right, so are the data consistent with this expectation? Conduct an appropriate test, assume the conditions for inference are met. Okay, this means we don't have to do that check the condition step. All right, well, I'm going to do, the test is actually done on the next page where I wrote it all out because I don't want to write it out or wait for you to sit here while I write it all out. But let's talk about how to get the expected counts because that is not a trivial thing, okay? We got 117 moose, and then this is the percent of the areas. So first of all, the observed counts obviously go into the observed list. That's fairly straightforward. What were they? 25, 22, 30, 40. 25, 22, not negative, 30, 40. And then I could put down the proportion of the area. Now this is not, I think some people put this down thinking they're expected counts. This is not the expected counts. 34, 101. 0.34, 0.101, 104, 455, 0.104, 0.455. These are obviously not expected counts. To find my expected counts, I simply need to take my sample size here times these proportions. That's going to give me the expected number of moose. So there were 117 moose, so I could simply take my proportions, bars, take your proportions, times the 117 moose. That was a total, right? 117 total. There we go. So these are expected counts. Now we can kind of evaluate this. In the burned area, you would expect 40 moose, but there was a lot less. So it looks like maybe they don't like the burned area. This is the burned area, but by the edge. Seems like they kind of liked it, almost double what you would expect. And then outside the burned area, or not in the burned area, but outside, looks like they expected like that as well. And for some reason, they didn't seem to like the area that was not even near the burned area. But the question is this a significant difference? Or could this just be chance variation types of differences? So let's run our test. Menu, statistics, stat test, goodness of fit, put in your observed, put in your expected, degrees of freedom. How many categories were there? Or how many responses were there to this one categorical variable? Looks like there were 4 regions. 4 minus 1 is 3. Test statistic, p-value very small. And here's the comp list. We're going to look at that. That's that component list I was just talking about. So let's just go back here to this. Look at what we got here. Null is the true distribution of moose in the region is proportional to the distribution of the acreage versus the distribution is not proportional. Goodness of fit, test statistic, p-value, conclusion, small p-value, less than that, reject the null. We have convincing evidence that the true distribution of moose is not the same, is not proportional to the acreage. Here's our expected counts. All right, so the follow-up question here is, relative to the portion of total acreage, which habitat types did the moose seem to prefer? The moose seemed to prefer the habitat type 2 and 3 as they had more moose than expected. Habitat type 3 was the most preferred because it had the largest chi-squared component at 26.1. So that's the answer. I guess I should have started with the... Let's take a look at the component list. So go to vars, go to stat component list, hit enter, and you can see this is the... So the first habitat type contributed 5 to this 43. The second contributed 8.8. The third contributed 26, and the fourth contributed 3.3. So this had the highest contribution. This had the second highest. But they all had a pretty good contribution here. So, but this was the largest. And it's not always the biggest difference, because remember that formula takes into account dividing by the expected counts. However, in this case, this was the largest difference also, right? It had a difference of 18. So when you do something like this, make sure you give specific numerical evidence. In fact, I don't like my response. I wish I would have said something like type 3, like say like the observed counts in 3 was 30, and the expected counts was 12.2. That is a big difference. What they want whenever they ask a question like this is they want specific numerical evidence. I did give this as specific numerical evidence. I did talk about more than expected, but on the AP test, really make sure that you're hammering away at specific numbers in cases like this. It's kind of like the proportions we talked about earlier. Instead of saying a larger proportion of guys than girls, give the number, like what proportion of guys did it, what proportion of girls did it. So be a little bit more wordy. Normally I don't say be wordy in statistics, but here wordy is good. Okay? All right, so that's the end of 11.1. We got one more section, chapter 11.2, chi-square test for two-way tables. We will do another video on that.